7.3, the parabola. Last time we did 7.2, the hyperbola, and 7.1, the ellipse. And a lot of this, we did a lot of the same kind of stuff, like completing the square. You'll have to complete the square and then verify what kind of shape is it going to be. Is it an ellipse, is it a hyperbola, or is it a parabola? So on the exam, there's not a ton of graphing, but there will be, you know, here is equation not in standard form. Can you put it in standard form and then make the conclusion what kind of shape it's going to be? The last section we're covering in chapter 7. So on chapter 7 exam, there's only 3 sections, which is probably the least amount of material on a chapter exam. And it's a week from Friday, so a week from today that will be covered. You might have done parabolas in college algebra, or you did something like y equals x squared. We started with this basic shape. Sorry, not college algebra, but intermediate algebra, math 110. Because we did a little bit of this with shifts, right? Shifts up, shifts down. Well, we're going to look at the parabola again, but we're going to look at it where we can have 2 extra things we're going to focus on. We're going to focus on the focus point of the parabola and the dextrous line. We'll also talk about focal diameter. So if we talk about having a lens that's shaped like a parabola, then there's a focus point in this lens, and then it has a focal diameter. So we'll go into a little more detail than we have maybe in Math 110. Your book goes over this little definition of a parabola. And a parabola is every point on the parabola is equal distance from the focus point to this dextrous line. Am I saying it wrong? Dextrous? Directrix? Directrix. Sorry, my brain and words don't compute. I'm not going to go through the proof here. Do I want to go through the proof? Yeah, I don't really think the proof is going to show us much. So let's just kind of look at applying this. Just like the ellipse and the hyperbola, we could have the major axis, the x-axis, or the y-axis. We can open in the x direction, or we can open in the y direction. Like the hyperbola, we're only going to open in one way, though. It's only going to open up or to the down or to the left or to the right, right? It's not going to open up and down or left or right. It will only open one of them. And then that will depend on the setup. Here, the general form, the axis of symmetry being the y-axis. This is what we're most used to because we're used to seeing y equals x squared. Okay, that's like the basic kind of relationship we have here. And if you think of graphing that, I have center at 0, 0, my vertex is at 0, 0, and I'm opening towards the y-axis, right? We also have maybe y equals minus x squared, and that's a reflection about the x-axis, right? Do you guys remember that from 110? Y equals x squared, the basic form of the graph. We did that in chapter 2 when we talked about shifting graphs. This is the basic x squared. What would happen if I shift it to the right or to the left? Well, now, the other type we have is, in this case, x equals y squared. If our coefficient, in this case, we call this p, is positive, we're going to open to the right. If our p is negative, we're going to open to the left. We're taking for granted for a little bit that our vertex is 0, 0. it might be shifted HK eventually. The focus point is going to be P units, either P units to the right, P units to the left, P units up, or P units down from 0, 0. Right? This would be P, this would be P. Our line here is also going to be P units in the opposite direction. Right? So the standard form is going to be x squared equals 4py or y squared equals 4px. Right? P units. So if we're opening up and down, our line is going to be y equals plus or minus p. If we're opening left or right, our line is x equals plus or minus p. Right? So these are the 4 cases. If our x term is squared, we're opening up or down. If the coefficient in front is positive, we open up. If the coefficient's negative, y term is squared, we're opening left or right. If our coefficient's positive, we open to the right. If it's negative, we open to the left. You guys get, that's like the basics of what's going on here. Let's look at the first kind of application is a word problem that has to do with a mirror. They don't quite give us the formula yet, but they're saying, or the formula is given here. Where should the bowl be placed to use the reflective property of the parabola? So the reflective property of the parabola would be to find the focus point. So this is a parabola centered at 0, 0, and it's opening upward because the x is squared. Yeah, but the y wasn't negative, or the p. This term here is 8y. And I could rewrite that in standard form, which is x squared is 4 times 2y. The 4 is kind of the standard part there, right? So the 2 tells me what p is. P is 2. So p units up from 0, 0 is the focus point. And p units down from 0, 0 would be y equals minus 2 would be the equation of the dexterous line. Do you guys see that? Question. Did I give you 7, 2? I'm sorry. I had it in 2 piles here. Here it is. 7, 3. Anyone else seen 7, 3? So find the location. Here would be 0, 2. So part A.
Why is it negative? Because it's always the opposite.
It's always the opposite of the way it's opening. Yeah. So the center at 0, 0. This would be the p-value, and this is also the p-value. The standard form is x squared equals 4py. And the p can be plus or minus. The 4 is the standard. Question.
In this example, x squared is 8y, or 13y. Will we need to divide 13 by 4?
Then so it'd be 13 over 4 would be the p.
Okay.
Yeah. So that's how you find the up and down. So let's look at this next one. Given the parabola, find the focus in the equation of the dexterous. So this is the form given. If I write that in standard form, I have x squared equals 4, 1 times y. This one value represents the p. I'm opening upwards because my x is squared. My focus point would be, what point would be my focus point? 0, 1. And what would be my dexterous line? Y equals -1. That would be the equation, yes. It's either y equals something or x equals something. Yeah, it's pretty straightforward. We'll get into a little bit more detail as far as the focal diameter and calculating the focal diameter. But other than that, it's pretty straightforward. And we'll also complete the square in examples like this as well. So let's look at this parabola here. Putting it in standard form, I could write it as x squared equals 4 times -3y. You always just pull out 4. Yeah, because if you look back up here to the standard form, there's always a 4 out in front. So you might, yeah, that's the standard form. So this P, yeah, this P is going to be the distance from the dexterous line and the vertex and the focus and the vertex. And P in the equation can be found by taking out the 4 from whatever coefficient is in front of the y or in front of the x term. Yeah, so if it's like 17, you'd write it as 17 times, or so you'd write it as 4 times 17 over 4. So P is 17 over 4 then. Here's a copy of the notes. Okay, so let's go back here. So this gives me P. It's negative, so it tells me it opens down.
Why wouldn't the 4 be?
It does. You could think of it as negative. It doesn't matter which one you think of it. The negative part or the positive part just tells you if it opens up or down or left or right.
So
Doesn't matter which one you look at.
I don't. I thought you said the x tells you if it goes up.
The squared part
Is that just like it goes?
tells you if it goes up or down
Oh,
or
okay,
left or
like
right.
The negative.
The negative tells you it goes down or left.
Okay.
Right? So the x part, if I have y equals x squared, that's the basic form. That's a parabola opening up, right? Y equals minus x squared is a parabola opening down. So in this case, I'm opening down. My center's at 0, 0 still. I'm opening down. My p-value in this case is 3 or -3. So 1, 2, 3, 1, 2, 3. My focus point would be 0, -3. What would be the equation of the dexterous line? Y equals 3. And the vertex? The vertex is 0, 0. The focus point, 0, -3. Focal diameter. It's a new thing here. Focal diameter is going to be the distance of the parabola that goes through the focus point, right? The focal diameter is always 4 times the absolute value of P. You can memorize that, or you could plug it in.
Wouldn't it always be?
This is.
It's a small thing, right? The 3 or absolute value of that, no matter what.
Mm-hmm.
That's wherever you start.
So it'd be the 12.
Kinda. That's why it's in standard form. For focal diameter, it's really easy to see. Here, it's going to be 12, right? One way to test yourself, y equals -3. This line is y equals -3, right? If I want to see where does it intersect the graph, that's going to be, when does x squared equal -12 times -3? So when does x squared equal, what would that be? 36. So that would be x equals plus or minus 6. So this point is -6, -3, and this point is 6, -3. So this diameter is 12. The diameter is always going to be 4p. One easy way to find the endpoints of the focal diameter is to plug in that y value or the x value, depending on if it's opening or closing, and solving for the corresponding x and y. Eventually, we're going to take this focus point and shift it, and then we might say, if this is 12 units, then it means I go 6 units to the right and 6 units to the left, right? So the 4p will give you the focal diameter. If you want the radius, you have to divide that by 2. Or in a sense, 2p. So another definition here, the lattice rectum here is the line that makes up the focal diameter. And a lot of times they'll want the endpoints of that on the graph. You guys see that? So here, I found the focal diameter to be 12. So that tells me I'm going 6 units to the right and 6 units to the left of my focus point. So if I go 6 units to the left, I'm at -6, -3. If I go 6 units to the right, I'm at 6, -3. And the last thing, the equation of the dexterous and the axis of symmetry. The equation of the dexterous would be y equals 3. And the axis of symmetry, what would be the axis of symmetry? It is the axis where you can fold it over and it's symmetric. The y-axis here, or x equals 0, or y-axis. When we're at 0, 0, it's either going to be the x-axis or the y-axis, but if we shift, it might be like x equals 3 or y equals 3. So kind of define things sporadically here. The vertex, the focus, and focal diameter can be found by just looking at the equation. Finding p, focal diameter is always 4 times p, and if you divide that by 2, you get the distance from the focus to the right. So let's look at 3 examples on your next page. I want you guys to spend some time with the first one, with the vertex, the focus point, and focal diameter. What would the vertex be? 0, 0, right? We haven't done any shifting yet. The focus point. 0, -2, right? The focal diameter is
0, 2. Oh, wait, no.
8, right? 8. The radius, the focal radius would be 4. And that's really what's focal diameter 8. That doesn't tell us too much. When we want the endpoints of the lattice rectum, we want to take 4 units to the right and 4 units to the left, or 4 units up and 4 units down, depending which way it's opening, from my focus point. Graphing the parabola here really kind of helps identify the endpoints. So this is a parabola that opens downward. And we said the vertex was at 0, 0, and the focus was at 0, -2. I might come in here because eventually we'll have to have this y equals 2 here. Looking for the endpoints. What are my endpoints going to be? Very good. -4, -2, and 4, 2. Right, because this whole distance is 8. So if I subtract 4 from my x component, I get -4. If I add 4, I get +4. So that's part B. Part C, write the equation of the dexterous, which would be what? Y equals 2, and the axis of symmetry. See, yeah. X equals 0, or you could say the y-axis. And I believe on Alex they're going to ask for the equation of symmetry because we're going to be shifting these eventually. So x equals 0 would be the y-axis. It's a little bit poor wording when they say axis of symmetry and they really want an equation. When we shift it, it will make more sense. This here, these endpoints. So the endpoints, if the whole diameter is 8, then the radius is going to be 4. 4 units to the left and 4 units to the right. So you always want to put it, the first step is to put it in standard form if it's not already in standard form. So the next example, what would it be in standard form? Equals 16x. And I could go one step further and have y squared equals 4 times 4x. Then I know p is 4. Be careful on this one. Which way is it opening? To the right. Well, you guys see that? That y is squared. So I'm opening to the right because my p is positive. If my p is negative, I'd open to the left. So graphing it. Where's my focus point? 4, 0, right? The x is 4 and the y is 0. Not 0, 4, 4, 0. I know this distance is 4. What is the equation of the dexterous line? I'm kind of skipping down, but x equals minus 4. But you're right, the focal diameter is 16. So the focal diameter is 16. How much am I going up and how much am I going down? 8, right? So if I go up 8, I'm at 4, 8. If I go down 8, I'm at 4, minus 8. So that's what my inputs look like. Endpoints. Write the equation of the dexterous. So what would be the equation? Yeah, the x equals minus 4. And the axis of symmetry would be y equals 0. Right, this right here, the axis of symmetry. If I fold this over, what line do I need to fold it over for it to be symmetric? So these aren't too bad, right? We've done much more complicated picking apart of the graph than the focus, the dexterous, the latus rectum, and the endpoints. What's going on in the third example here? Which way is it opening? Left, right? So you can see how you just look at it and you know it's opening to left. So some of them on this next exam and on the final, I'll just give you graphs of 10 different shapes and 10 different equations, and you'll have to match them. So you don't have to go through and graph every single one of them. You can say, only one of them opens to the left. It has to be this equation. And you can match it. Only one of them is a hyperbola. So it has to be the one that has the hyperbola relationship. So here, putting it in standard form, I have y squared equals minus 4 times minus 3x. I know it's opening to the left. What is my focus point? Minus 3, 0. What's my dextrose line? X equals 3. Right? Focal diameter is 12. Focal diameter is 12. Focus radius is 6, right? The radius is 6. So the endpoints here, I go up 6 and I go down 6. So my X points stay the same. And my Y point goes from 0 to 6 or 0 to minus 6. You guys see that? So the endpoints are actually pretty easy to find. Once you know the focus point and once you know the focal diameter, find the radius and go up that much and down that much, or to the left that much and to the right that much. Only one of the components are going to be changing. The other components stay the same, right? Minus 3, minus 3, minus 3. I only have to worry about changing one of those. Dextrose line, y equals 3. Axis of symmetry, y equals 0. So our life's pretty easy at 0, 0, but it doesn't get that much more complicated when we shift it. As long as we're consistent by knowing the x values aren't going to change here, or the y values aren't going to change here. So P still represents the distance from the vertex to the focus point, right? So here the vertex is not 0, 0 anymore, so you might have to add, if you're opening up or down, you might have to take K plus P, and P might be positive or negative, right? Or H plus P if you're opening left or right. And the other component doesn't change. The axis of symmetry is actually going to be an equation. Again, I don't know why they use the term axis here. It should just be x equals or y equals. I think that, this isn't too helpful if we just look at an example. So first example here, what is my vertex? 2 minus 3, right? 2 comma minus 3. What is my focus point? It might be helpful to kind of graph it. So I go 1, 2, 1, 2, 3. I kind of need to ask myself, am I opening up or down or left or right? Up or down? The
Y squared.
It's left or right, right? The y is squared, so that means I'm opening to the left or to the right. My coefficient in front of here is negative, right? So that means I open to the left, right? So that will tell me that this y equals 3 line, sorry, y equals minus 3, that's my axis of symmetry. That's where I'm going to move my vertex up or down. Or, sorry, my focus point, P units. So what is P in this case? P, you could say is -1 or just 1, because I go positive and negative. So this would be my focus point, and this would be the equation of my dextrose. So what is my focus point? 1 minus 3. What's the equation of the dextrose? Is it y? X equals 3, right? What is my focal diameter? Four, right? So focal diameter here is 4, and the focal diameter would be 2 units up from my focus point and 2 units down, right? So what are the endpoints? One minus 1 and 1 minus 5. So my picture here, if you look at the axes, are a little misleading because I have 1 minus 1 is above the x-axis. It should be below it, but I just kind of threw it on there. But you see how the x component does not change? X equals 1, x equals 1, x equals 1. Only the y component changed. And the y component from minus 3, I went down 2. So I went to minus 5. And from minus 3, I went up 2. So I went to minus 1. So the endpoints here are going to be 1 minus 1 and 1 minus 5. That's usually why they say graph it after you do that, because now that once you have it, you can kind of get a better picture of the graph of it. But I kind of think if you just kind of sketch that in there, it gives you a better representation that I'm not going to change my x at all. I'm only changing my y. What's the axis of symmetry? Y equals minus 3. Okay, see those? I want you guys to work on the next one. Focus is going to be p units up or down or left or right from the vertex. The vertex is at 4 minus 2. So is it opening left or right? Left, good. So if I'm opening left, I'm going to go 4 units left. This is 4, 2, or 4 minus 2. And the focus, what's P? P is, well, take out 4. It would be 2, right? The negative is 1. So yeah. Yeah, and y equals 2 is going to be your axis of symmetry. Yeah, P here is 2, not 4. If you take out a 4, you're left with a 2.
Right.
Yeah, the 4 is the standard. The focus is always p units to the right or the left of your vertex. And p is always in standard form. You factor out a 4 from the coefficient. So here this would be x minus 2 quantity squared equals 4 minus 2 x minus 4. So this is p. And then it will tell you if it opens left or right. The endpoints. The axis of symmetry, blank distance. X equals 6 to the vector. Yeah, yeah, that helped. Four, two, they're going 2 units, yeah, so, yeah. So this would be. Well, two this way. Two this way would be 2, 2. The y is not changing. The y stays the same. Only the x changes. Right, if I move this way, only my x is changing. Yeah. Equation x equals 6. Equation of the dextrous. In this case, because I'm already at 4, p is 2. So I move 2 units left of p and 2 units to the right of p. One of those is the equation of the dextrous, the other one is the focus point. P just gives you the distance from the focus point. Right. So if you have the focus point, so here you have the focus point is at 4, 1, 2. So if I go 2 units to the left, I'm at 2, 2. If I go 2 units to the right, I'm at the equation of dextrous, which is x equals 6. Right? So at 4, 5, 6.
So how do you know that's the x equals 6?
The equation of the dextrous. The dextrous is always opposite of the way the parabola is open. The axis of symmetry is going to be where what line goes through the parabola where if I fold it over it's symmetric. So whatever makes sense, it could be x or it could be y, depending if you're opening up or down or left or right. Here I'm opening to the left, so my y equals something is going to be my axis of symmetry. My x equals something is my dextrous line. And this was what I was going to do at first, is just prove to show where y and p and x, where all that comes from. But it's kind of messy and uses a different formula, and I don't think it's beneficial. It's kind of hard to walk through that. Just know p is the center to the focus. The vertex to the focus and the vertex to the dextrous. That's p. Wherever it's in space, if it's 0, 0, it makes it pretty easy. But if it's any other, you have to be careful. What am I changing? Changing my x values by p. Leave the y values alone. Or I'm changing my y value, leave the x values alone. So, yeah. Good.
Based off
It's,
the
yeah, but,
focus.
yeah, this is actually the focus point here. And it's at 2, 2. If I go 2 units here, only the x changes 2. All, right? You went 4. So then this line is the lattice rectum. The endpoint of the lattice rectum is going to be, in this case, since it's the diameter is 4, I go 2 units up and 2 units down. So if I go 2 units up, I'm at x equals 2, 4, because I go 2 units of 2. And then this would be 2, Yeah, it should have been 2, 2. So if you went to -2, now you would say this is 6. This distance is 6. But it corresponds to p, and p is 2.
the distance from this point to the focus point is only 2 units.
I did that on starting with 1, 2.
Yeah. The best thing you can do for these is practice and get more experience with how to get it in standard form. The standard form is something squared equals 4 times p times x minus something or y minus something, depending on if it's opening left or right or up or down, right? That's the general form. Then knowing from the general form, the vertex in this case is 4, 2. So I go to the right 4 and up 2. So this is 4, 2. The focus point, I'm going to go ahead and draw on the focus point. The focus point is going to be 2 units to the left. So if I go 2 units to the left, I would be 2, 2, right? This distance is p. The equation of the dexterous, 1, 2, would be 2 units or p units to the opposite side of that. I'm going to go ahead and write here x equals 6. The endpoints of the lattice rectum is going to be where x equals 2. Or I know that the focal diameter here is 8. Right? The focal diameter is 8. Tells me I go 4 units up and 4 units down. Make sure I'm saying that right. Yeah, 4 units up and 4 units down. So 4 units up, the x does not change. So this would be 2, 3, 4, 5, 6. So this point becomes 2, 6. And if I go 4 units down, I go 1, 2, 3, 4. So this becomes 2, minus 2. So this gives me a really easy way to graph this because I know those 2 points. Vertex is at 4, 2. Focus is at 2, 2. The focal diameter is 8. The endpoints are at 2, 6, and 2, minus 6. Sorry, 2, minus 2. The equation of the dexterous is given as x equals 6, and the axis of symmetry is what? Y equals 2. So I gave you a few more examples on the next page that you actually have to end up putting it into standard form first. So you have to complete the square and then answer the same questions we've been answering. And the last thing we'll do is I might give you the focus point and the dexterous point and the vertex and have you come up with the equation, just like we did in the other 2 examples. So we will start off on Monday at this part of the notes. Monday we'll finish 7.3. Hopefully I'll get to pull up Alex and do the Alex type questions. Wednesday we're going to review, so I'll give you a review handout. Probably on Monday I'll give it to you that has 7.1, 7.2, and 7.3 on it. I'll answer any questions in class on Wednesday, and then Friday's the test. 7.1, 7.2, and 7.3. I'll see you guys Monday. Have a nice weekend.